In this video, I want to show you a method to take orthographic views and translate them into a perspective drawing by projecting related points back in space and finding where they meet. But before I do that, let's quickly review what orthographic drawings are and what purpose they serve. Orthographic drawings are a series of two-dimensional drawings to communicate scale and detail of a design. Here's an image of a stool in perspective, and here are the orthographic drawings that would be produced from this stool. The three drawings depict the stool as it would be seen from the front, from the side, and from the top, which is called the plan view. As designers, quick, iterative perspective drawings will be our primary tool to develop our ideas. But when it comes to communicating our final design to a manufacturing partner, we'll want to use orthographic drawings so nothing is miscommunicated. It's useful, then, to be able to look at orthographic drawings and understand how all the lines and surfaces meet in 3D space. So for these exercises, we'll be doing just that. You can see, even though they look identical, that I have a front view and a side view, also called elevations. I have a top view as well, but for this demonstration, let's just focus on the elevations. I've constructed a frame using the same measurements as the elevations, and now I can lightly draw the elevations onto the frame. We'll just be using these as references to find out how they converge in perspective space. To draw the elevations onto my frame, I'm visually estimating how the squares would break up into halves and quarters to give me a more exact grid to work with. If you'd like, you can always subdivide your frame into smaller squares to give yourself more exact reference points. It won't take too much more time to draw out the subdivisions on your grid, but you'll also have a lot more lines on your page, so consider if it's worth the trade-off. Now I want to find the top surface of my stool, so I'll take this point, and I'll find where they intersect in 3D space. I'll take this point and drive it back, and take that point and drive it back. Now I'll do the same with all the other points. And that has given me the top surface of my stool. My next step is going to take this side elevation and tip it. The reason I need to tip it is because you see I have this larger trapezoid, and I have a smaller trapezoid, and I need to know what those look like in perspective. To do that, I'm going to draw this front edge, which is going to start here and meet down at the bottom corner. I'll do the same for this back left edge as well. And the back right. And I'll darken up the lines for the top of my stool as well. What I'm going to do next is I'm going to take this smaller trapezoid and lean it against the surface that I've already created. So I'm going to focus on this line first. I'm going to take this point, and I know it's going to go back in space, and its intersection is somewhere on this line. But I don't need to guess. What I can do is I can take the line, translate it forward until I find the front corner, and then I project that over, which will give me this point right here. I can take that point back, which will give me this point in 3D space. So if I take this line and I lean it, I know it's going to end right there. I can do the same thing for this line. I'll take this point, send it back in space, and since I've already projected this line over, it makes finding the intersection much easier. And now I can draw in the top. Now I'll do the same for the right side. I'll take the elevation and I'll tip it. Again, I'll need to find the top of my smaller trapezoid, but since I already have this line, I'll just project it over from the left side. I'll project both of these points back, which will give me the top surface, and now I know where all of my lines go. To finish this off, I need to draw on the footrests. But since I've already projected my smaller trapezoids, it's going to be so much easier. I just need to take each point and project it back until it intersects with the trapezoid lines that I just drew. Now I've used both of these elevation drawings to draw two surfaces, but I've yet to give the surfaces any depth. Before I give depth to the stool, I need to explain the use of dotted lines in orthographic drawings. Sometimes, orthographic views can't show you every edge, since lines that define a surface may be obscured by other surfaces. When a designer needs to show a hidden edge, they will often depict it with a dotted line. Looking at our stool example, to communicate a stool design like this, with 4 separated footrests, our elevations would need to look like this. However, if we were to remove these 2 dotted lines, it would communicate that the footrests had no interior surfaces, so they were instead a single surface, like this. The elevations I'm using for this demonstration don't show any dotted lines, but for your reference, I'll be drawing the former design with 4 separated footrests. To find the inside corner of this footrest, I need to project this point back, and take the point on the opposite elevation that depicts where that point is in space. But which point do I use? One way to figure it out is to draw one of the lines. Then imagine where that line would be depicted in the opposing elevation. Translating this point forward, we know that it starts here on our elevation. Now let's imagine a line from that point. When the line you drew meets a corner or edge, there's a good chance that's a point that needs to be projected back to the vanishing point. But make sure the line is at the correct height, otherwise you may find a false intersection. I'll draw in the top surface of this footrest. Then I'll continue building out the other surfaces of this stool, using the same technique of projecting corresponding points to their respective vanishing points, and finding where they intersect. To finish out this drawing, I'm going to go back over some of my lines. For any edge where the second surface faces away from me, I'll make it a little bit thicker. Any edge where I can see both surfaces gets a slightly thinner line. This is a simple technique you'll see in a lot of industrial design sketches to help communicate depth. And with that, I have a finished drawing that I created using 2 elevation views. I hope you found these tips helpful. Thanks for watching.